Is anything truly random? The roll of a die could be predicted with the exact forces acting on it and the exact state of the particles in it. Even people could be predicted with the exact states of the particle in and around them. Since we don't have that kind of technology, things like people and dice are random to us, but not to the universe. Is anything truly and intrinsically random? Well, there are some things, but they are very small. In my video about the smallest thing, I told you what the smallest things in the universe were. These tiny objects act very strangely. The fact that they act differently when they are being observed compared to when they aren't being observed is the main thing. Through indirect observation, we have seen particles acting differently from how they act when we observe them. Everything in the universe acts like a wave and a particle at the same time. It isn't noticeable on the scale of people, though. However, on the scale of particles like quarks and leptons, it is visible. For objects like electrons, their position is just a wave of probability. Until you observe it, the electron isn't in one location, it's everywhere on the wave. Since the electron would be in many places at once before it is observed, it would be in a superposition. A superposition is a combination of every possible state or position a particle is in. And surprise, surprise, the superposition of the electron is the waveform of the electron. This brings up a famous thought experiment, the Schrodinger's cat thought experiment. If you put a cat in a box with a poison that has a 50% chance of releasing, is the cat alive or dead before you open the box? The answer is both. The cat is in a superposition of alive and dead, just like how the electron is in a superposition of many different locations. But when you observe the cat or electron, the superposition collapses into one state. An experiment called the double slit experiment shows this. Electrons being shot at a plate with two holes in it were measured to form waves on the measuring plate behind it. Basically, if the electrons acted like large objects like baseballs, there would be two concentrations of electrons behind where the slits were. But instead of that, they were found to go far from the slits, like two ripples in water interfering with each other would. This shows electrons acting like a wave, remember ripples of water, and a particle physically being in a place at the same time. This is very interesting. The position of the electron is random with different probabilities. Imagine the position of the electron being determined by a wheel of fortune wheel turning. It's random. This is one of the small processes that allow for randomness in the universe. Particle decay is when an unstable particle changes into a stabler one. The unstable particles last a certain amount of time before they decay. It isn't a set amount of time, though. It is a random amount of time. How is this randomness determined? The particles have things called half-lives. A half-life is a period of time that, after it, the particle has a 50% chance of decaying. Now, half-lives can be very long or very short, but either way, all unstable particles have them. So this means that any given unstable particle could last forever or could decay instantly. It just has different probabilities based on its half-life. These two random processes make the universe random. Part of quantum mechanics, called the Heisenberg uncertainty principle, makes it impossible to know everything about the state of a quantum particle. You could predict the many ways that the universe will unfold by taking what you do know and filling in the gaps with the possible random states. But this would take very advanced technology and would give you so many ways that the universe could go that it would be pointless. What if each time a random process happened, the universe split into each outcome? This is the many worlds theory, and my next video.